In this episode, I'm gonna prepare so-called repositories and services. Before we'll dive deep into code, I want to present you what repositories and services are and what we are using them for. To indicate that certain class is a repository or service, as always we mark that class with annotation. All those two annotations inherit from add component annotation that Spring is using to auto-detect and register automatically that class inside configuration. To picture relations and responsibilities of repository and service, we will use bank analogy. Repository is like a vault where your fortune is stored, and service is like a teller, whose deposit, withdraw your money, and in general is managing your account depending on your needs and orders. Speaking in more technical terms, repository is like a data access object that's sending queries to database to receive and save data. Service, on the other hand, is combining different requests and preparing everything all together to deliver you certain data or achieving certain results in database. These annotations are basically used to indicate purpose of certain class. Annotation itself doesn't do much in terms of functionality. With this basic knowledge, we are ready to prepare these layers inside code. Create new directory called repository. Inside repository directory, create interfaces directory. Creating interface for each repository is a good practice and mandatory in some cases, but I will present it later on. Let's prepare a repository for our first model, customer. You can create interface with IDE Creator or do it manually. In our repository, we want basic Crud operations, which stands for create, read, update, and delete. It's a popular pattern of designing database applications with user interfaces. To all of you beginners that doesn't know what interface is. Interface is like a schema that we have to follow during creating our class in order to fulfill requirements outlined by interface. What kind of methods certain class has to implement in this case? Okay, so what we want is to add customer that return boolean value true if customer was added successfully and pass customer object. We want delete customer with the same values as before. We want to update customer information. Next, we want to get customer by username for login and administration purposes that takes username and return customer object. After that, the same operation, but we want to get customer by ID for purpose of use inside services. At the end, we want to get list of all users for admin purposes. Once we've done that, let's create class itself. Create file with the same name outside of interfaces folder, but with implement appendix. This class implements our newly created interface. Assign add repository annotation to mark this class as a repository class to let Spring Boot discover it. JetBrains IDE has auto-implement methods option that let you create all methods by just one click. Before we start filling our methods with logic, let's inject protected field of Entity Manager. This interface is our bridge between database and application. with persistence context annotation is used to do all queries automatically for us with all open and close connection baggage hidden underneath. Let's implement first logic to add customer to database. Create try catch block in case of failed operation. Use merge method of our entity manager object to persistence customer. Merge method can be used to save and to update customer as well. In case of failure, return false, and if operation was successful, return true. To delete customer, we use similar approach but invoke remove instead of merge method. To indicate this method to do all persistence operation underneath automatically, add transactional annotation to it. What this code does is creating session factory with configuration. Getting session, starting transaction, doing our code in between, committing transaction and closing transaction at the end. Using this annotation is so convenient, as you can see. To update customer, we declare customer object, and inside try block we use find method to get related customer from database by its ID. We pass customer class to indicate in which table we are looking for our object. Next, we assign all values from pass to method customer object to newly obtained object from database. We do this operation because otherwise Hibernate would try to create new object inside database instead of updating existing one. Everything is located inside try catch block, so in case of error our code returns false value. I will zoom in a bit to give you a better view of what is going on. Sorry for this typo, here of course supposed to be username. Correct it also inside interface. To get customer by username, we declare list of customers. Inside try block, we invoke create query method. Here we type SQL query where we compare record by its username value. After that, we invoke setParameter method to inject passed string name variable into SQL query. First parameter is a username variable related to one inside SQL query, and second is our string passed to the method. At the end, we invoke getResultList method to get list of matching records. In case of failure, return null value. Because we want just first result, we return just first value from our list. To get user by its ID, we do the same operation like the one we did to update customer information. As always, return null in case of failure. To get all records from customer table, we invoke createQuery method with simple SQL query passed in to obtain all values. Remember to invoke getResultList method to, of course, receive list. Catch error and return null. Return ArrayList of customer objects in case of successful operation. Don't forget to assign addTransactional annotation to each method. Our customer repository is ready to go. Now it's time to create next in our sequence tables order repository. Create order repository interface inside interfaces directory. In this case, to omit boilerplate code of basic Crud operations, let's extend this interface with JPA repository interface with order and long passed in as a template variables. Order to indicate related table and long to point out of which type is our ID column. Previous example was to demonstrate different approaches, in this case deprecated approach's previous one. Because we want to have custom more complex query, we extend it with our own method to get list of orders based on customer ID. Customer ID of type long as always. JPA repository is like a factory, which will create automatically desired operations for us. Our order repository is finished. We don't have to implement this interface because injecting it to service will be enough to use all persistence capabilities. Thanks to JPA repository interface. Next, create detailed order repository interface in the same directory. This interface will be extended just like the previous one, but with detailed order generic type. In this interface, we also want custom database operation to get list of detailed orders based on order ID. Order ID of type long. Last repository to implement is product repository. Create product repository interface. In this case, we will follow old-fashioned approach. This interface includes end and delete product methods. Get by product ID method. And last two methods for search engine on website to get list of products by name and category. Last method is to get the list of all products. Create product repository implementation. Assign add repository annotation and implement product repository interface. Create automatically all methods if your IDE let you do that. Like in customer repository, first we add protected field of entity manager with add persistent context annotation. To not forget, let's first assign add transactional annotation to each method. To add product, we follow the same path. Creating try-catch block and using entity manager to merge passed product to method. To get product by ID, we declare product object, and inside try block, we try to obtain product from database by invoking find method of entity manager. Return null value in case of failure. Copy this code to next method. Change product class to product list. Inside try block, change find method to create query method. Let's write simple SQL query where we compare product's name to parameter that we pass to set parameter method. Question mark with number 1 is used to indicate query variable from outside. Set parameter takes first number the same as 1 inside SQL query and second parameter variable that we want to inject. Percentage symbols assigned to beginning and the end of variable indicate that we are looking for product that contains this sequence of characters. It can be just one letter, for example. At the end, as always, we invoke getResultList method. Copy this code to next method. Logic will be the same, but instead of comparing names, we will try to find exact the same category to one that we will pass to setParameter method. Once again, copy this code to last method. In this case, reduce SQL query just to select all records from product table. Invoke method to get result list. Catch block return null in case of error, otherwise return list of products. All repositories are ready to go. Now create new directory called service. Inside this directory, create interfaces directory. Let's start with customer service interface. Opposite to repository interfaces, these interfaces are plain, pure, and not extending any other interfaces. Methods that we are gonna implement are pretty much the same as those we created inside repositories. first two are prepared to create and delete customers by ID. Next, login method takes username and password as a string to authenticate users. After that, we have method to update customer. Last three are getters to receive customer from database by ID or username or get list of all for administration purposes. Like with repositories, create class implementation. Implement all methods from this interface. Assign add service to indicate this class as a service. Before filling our methods, we have to inject customer repository. Create private field of this repository and generate constructor that assign repository to its field. Spring recognizes that kind of constructor and automatically wired repository with this class. Inside first method, we just invoke method of repository to add customer and return result of this operation. That's it. Next method is a bit more complex. First, we declare customer, next try to get customer of this ID from database. If customer exists, we delete customer from database by invoking delete customer method of repository. To log in user successfully, first we have to try to get customer of given username from database. If we achieve this, next we compare if passwords from database and passed to methods are not equal. Don't use double equal sign because you will only compare references, not actual values. If they are not equal, return null. Otherwise, return customer. To update customer, we just return value from invoked repository method. We do the same operation to last three methods. Customer service is ready. Now it's time for order service. Create order service interface. First method is to create order of customer of certain ID and based on past detailed order. Then we have method to simply delete detailed order by ID. setOrderDelivery method is used when order is finalized and current date is assigned to delivery order column. Last two methods are getters, first to get by ID, second to get all orders of given customer ID. Create class that implements this interface. Don't forget to assign annotation. In case of this service, we need 3 repositories injected, because createOrder method requires it. To explicitly underline that this constructor is wired with repositories, you can add auto-wired annotation, but it's not mandatory. First stage of creating order is getting customer from database by ID. Obviously, if customer not exists, return false. Second step is to get all orders of given customer. Declare order. Then we look through list of orders to check if already there is available created but not finalized order. Not finalized order doesn't have set delivery date. If we find one, we assign this order to previously declared. If order was not found, we create new order. Now finally we can add pass detailed order to this object. After that we have to assign this order to customer that we received. When everything is linked together, we can eventually persist created object with whole relationship in database. We use automatically provided method from JPA repository. I will zoom in a little bit to give you a better glimpse of what is going on here. After all, return true value, that means that operation was successful. To delete order, we use old try and true try catch block with invoke delete by ID method. Inside setOrderDelivery method, in a first step we try to get order by using one of already implemented method. Of course, return false if we don't succeed. Now do the main goal, which is to set actual date to order delivery. This means that customer bought certain product or products, so we have to update amount of currently stored products inside product table. Get list of all detailed orders of received order. Next loop for list, and for each detailed order get its assigned product. Once we've got a product, we can change the amount of that kind of item stored inside storage. To do that, we can subtract ordered amount from actual number of items located inside storage. At the end of block of code, save changes. All operations are done, so we can save changes made to order and flush. Return true value of successful action. Last two methods are just pure invoking of methods from repository. First to get one order by ID, second to get list of orders by customer ID. Next stage, detailed order service. Create detailed order service interface. First method is to create detailed order by pass detailed order object to this function. Next is to remove detailed order by its ID. After that, we have getter to obtain detailed order by ID. This method is to change and update amount of ordered product of certain ID. Last two are getters. First to get detailed order list by order ID, and second to get all detailed orders. Create class implementation. Create methods and assign annotation. Set private field of detailed order repository. Create constructor with auto-wired repository. To create detailed order, we will cover invoking method from repository with try catch block. Same with remove method. Getter will invoke method of repository and return Boolean result. In case of setting amount of detailed order, we have to first get detailed order by ID, check if exists, next get product related to this detailed order. This if statement checks if operation is possible by checking if amount that we want to order is available inside storage. If not, we return false, which means setting amount failed. Otherwise, we assign amount and save changes. Last two getters are simply invoking repository methods and returning outcome. Final stage, preparing product service. Create product service interface. First method, as always, is to create product itself. Next one is to delete product by ID. I will zoom in a bit. Rest of methods are getters. First we get all products from database. Next two are to get list of products by name and category, and last to get one product by ID. Create service implementation. Generate methods and add service annotation. As always, create private field of product repository. Create constructor with auto-wired product repository. To create product, we simply invoke add product repository method and returning result. To delete product by ID, first we are trying to get certain product and then pass obtain product to delete method of repository. For the rest of methods, we simply invoking repository methods, passing arguments to it and returning results. I hope this tutorial was useful and clear enough for you to understand the concept. In next episode, I will prepare REST controller with logic of API endpoints. Thanks for watching.